Good morning, everybody.
Good morning, sir.
Sit down, sit down. How are you feeling today?
Good, sir.
Yes, sir.
Good.
Refreshing, right?
Yes,
So
sir.
I am also feeling refreshing, but little bit headache. So no worries. So let us start our class. Before that, what do you think of yesterday? What do you think of yesterday? Is it good or bad or worst? What do you think of yesterday? Is it good? Okay. Next, what do you think of yesterday?
Good, sir. Very good.
Very good. Very nice. You, sit down.
Average.
Average. Right? Next.
Very bad, sir.
Very bad. You? Good. You?
Good, sir.
Right. Thank you. So yesterday I was feeling irritated, and it is very very bad day for me. Okay. So why sir? Why are you telling all these things? Why you are asking about mood? Right? So our mood decides. Our mood decides what to listen, what not to listen. Am I right?
Yes, sir.
If you are in good mood, you will listen to the class. If you are in a bad mood, like our Manasa, great, you won't listen to the class. So to make it good, let me tell you one story. A simple story which gives 10 seconds, okay? Right? So one person is traveling on a road, okay, by walk. He is going by a walk. Suddenly he saw something is shining near that beside the road. Okay. Generally, if anything shines, what a person thinks?
Gold, silver.
First they will think that, is it a coin? Huh? Where is that coin? It should be mine. If any silver is there, if any gold is there, okay. Diamonds won't be visible at the roadside, amma. No need. So first person will think that is it a coin, right? So it shines. So he went there. Eagerly he wanted to see what is there, and he went there and saw a small piece of glass. He was so disappointed. Next few steps he was walking. He is walking, and again it started to shine again on the left side of the road. He thought, okay, that is also maybe a glass. Okay, let's see for this time. So he went up. When he went there, he saw a steel glass. What is this? My day is very bad day. I am thinking about the gold and diamonds. This is not at all good. So again he started few steps, and he saw so many things are shining over the right side. He thought, some stupid fellow broke the glass, and some stupid fellow broke the things and thrown over there. So why to bother? Let us do. So when he is going, the shine becomes brighter and brighter. Okay, the shine becomes brighter and brighter. So he was struggling inside the mind to go or not. If I go, if it is a bottle, I will feel depressed. If I don't go, I may miss something. So he's struggling in that. So finally he got struggle, and went and watch over there
Molasses.
and saw a big pile of silver coins. You know, big pile of silver coins, which is thrown away like that, just like that. And he saw all those silver coins, and what he did? He carried all the coins and went away to home. Happily, whatever he wanted, he buy. He ate whatever he wants. He brought things to his home, and he was happy. So, what is the moral of the story?
Don't be disappointed.
Never give up. Okay. So, in life, when you are traveling, some things look shiny, but if you go with eagerness, that is not the time you will get. Okay. Second time also it may shiny, but that is not the time you get. But when the time comes, that only will come to you. You people are so excited about wearing new dresses and keeping cool goggles and chains and having boyfriends and girlfriends, doing everything. You people are so interested. But this is not the Okay. So in future you will get the time and then you will enjoy the fruitfulness. Like that he found all the silver coins and when he got to home, one coin he took and he observed and thinking about that coin. Okay, silver, what it is made of? Is silver is made like that coin or if it is it available in somewhere else? He began to think. Then he was a student of my class in ninth class. Okay. So when I am explaining atoms and molecules, he was there. So he began to think that okay, this coin is made of silver. Silver comes from where? Earth. Silver comes from earth, right? So directly it is coming like that or somebody is making it to silver?
Directly it is coming.
Directly it is coming like a coin.
No, sir. Somebody is
No.
making.
So first of all it will come like a stone and then we refine it and then it will be made into a silver. Now he almost went into that lesson which I taught before and he began to think what are the types of atoms present in this silver. So today we are going to see what are the types of atoms present in each element. Okay. And do we call all the elements as atoms or do we call some elements as molecules? Okay. So our lesson today is atoms and molecules. Atoms and molecules. So each element, every element, whatever you see is made with
Atoms.
atoms, right? So what kind of atoms are there in wood, Kirtana? Okay, whatever the element you know. Iron, very good. So what type of atoms are there in iron? Iron atoms, simple, right? So what kind of element do you like? Gold. Good boy. So what kind of element is there in that gold? Gold. So do you see that? Okay, she likes iron. Did she see any iron atom is present in that? How she knows? So he may have seen gold. Okay. But any golden atom is visible? Not visible, right? So we can understand atoms are not visible with our naked eye. And they are very, 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 very tiny particles, tiniest particles. Okay. Right? So atoms are tiny particles. Okay. Now, coming to these atoms, there is an interesting concept. So we all know that when a candle burns, the candle size is reduced. We all know that when we burn agarbatti, it becomes into ashes. We all know that when we boil some water, it will become into vapor. So we all know that when we cook
Food.
eggs, okay, when we boil eggs, what happens? It will become hard inside, right? So the liquid inside also becomes hard. So here we can see every day there is a change in the state of matter. Okay. So all these elements are made up of what? Matter. All these elements are made up of matter. So all these elements which are made up of matter change their state. Now what are the types of matters? Solids,
Liquids.
liquids,
Gases.
gases. So we can understand the elements which are solids can be in liquids and also can be in the state of gases. The elements which are liquids can be in gaseous
Solid.
state or also solid
Solid
state.
state.
In first lesson we have learned all these things, right?
Yes, yes.
So now we are going to see when it is converting from solid to gas or solid to liquid. Any example? Ice cube, very good. So if you take ice cube, if you take ice cube, what happens? It is a solid. Now it melts and become into liquid. So the ice cube have different kinds of atoms and water has different kinds of atoms? No, same types of atoms. For example, this ice cube is weighing 2 grams. When it becomes to water, how many grams of water will be there? How many grams? 3 grams? 2 grams of water, right? Right. So here we can understand how many number of atoms are present in the ice cube. That is same in the water itself. So that we can see this ice cube is not at all changing its what? Huh? Say loudly. Mass. So mass is not at all changing. So we have a clear picture that mass stays constant whether the matter changes its state. What is constant? Mass is constant when the matter is changing its state. Now let us see some pictures. I will show it to you. I brought a pen drive. So as we have seen, atoms is composed of tiny particles. So you can see here, this is a matter which is in the solid form. And coming to the liquid form of matter, all these things are developed into tiny particles. And each particle looks like this. Each particle looks like this. Okay. So let us see next picture. Yes. This is a cube of sugar. Every day you people use sugar, right? For example, when you are at home, mother will make all kinds of sweets and all to eat. So in that, what they will add? Sugar they will add. So how many of you tried to see single grain of sugar? How many of you tried? And how it looks like? Can you draw? Anybody? Anybody of you tried? Single grain of sugar? Did you try? You saw? Okay, can you draw the picture? No? Right. Very small, right? So if you want to see the single grain of sugar, let us see. See, it looks like this. Single grain of sugar. Okay, single sugar crystal, if we say, that is better. Okay, we call that sugar as crystals. So when do we say it is a crystal? When it is a molecule. We will get back to that. Okay, right. So single crystal of sugar looks like this. So if you take 1 teaspoon, okay, if you take 1 teaspoon, how many crystals of sugar will be there? So before we have seen what we have seen. That one. In 1 cube, how many crystals of sugar will be there? Millions of crystals. Okay. We can just say uncountable because we cannot take each and every crystal and see it with our naked eye. It is not possible. So simply we will measure the mass of the crystal and shape of the crystal and we calculate how many crystals can be fit in that. Did you understand? Right. So now the question is, how many atoms are there in a single crystal?
Millions.
Huh?
Billions.
Millions is very, very less number.
Trillions.
Trillions is also very less number.
1,000 trillion.
So there is a new word which shows, yes.
1,000.
So it is a new word which we don't know actually, sextillion. So it may mean either of two numbers, like see how many zeros are there? 1000 million 10 power 21. 10 power 21 atoms are there in single crystal of sugar. Single crystal. Now you may have seen sand, right? See, I brought this. So if you do like this, sand will fall, right?
Yes, sir.
So can you catch a single grain of sand? So on my finger, so many grains of sand is there. So in this single grain of sand, first of all, how it looks like, let us see. Single grain of sand looks like this. So it is also the form of crystal, right? How many atoms are there in this single crystal?
61.
Huh? 63 atoms. Where is the yes grain of sand? How many are there? Count 10 power 20. So which is less than sugar crystal. Just imagine if 1 crore of cash is there kept here, how it looks like the bunch. Okay, just like now notes are 500 rupees. Okay, we can just make it into this much square. If 100 crores of rupees are there, so at least 2 rows will be occupied. If million crores are there,
3 more rooms.
total class will be occupied. If million trillion crores are there, this whole classroom is occupied. And if that is a single atom, if each note is a single atom, it won't occupy the whole class and it will occupy only the single grain of sand which we cannot see properly. Understand? So that much smaller the atoms are. Got it? Understood? So now let us see even more so that we will get an idea what is this atom. For example, dust. So normally outside we will see dust, right? So as per the research, in dust there might contain, the atoms might contain 3 into 10 power 12. We just saw 10 power 20, 10 power 21. But here in the dust, 3 times 10 power 12. 3 times 10 power 12. Just imagine if that each atom is a ball. For example, if that each atom is a small plastic ball. Now just use your brain how much space it will occupy. The whole Gajuvaka will be filled with balls. Am I right? But that much space occupying atoms are present in single flush of air. That means when you are riding on the bike, some dust will come and stay in your eyes, right?
Yes, sir.
So the total dust is counted as 3 into 10 power 12 approximately, not sure, approximately, but not less than that, right? So like that we can understand these atoms are very small, right? So let us see more. What is this? Can you guess?
Ice.
No? No?
Salt.
Salt, very good. So this is a salt crystal. How many types of, how many atoms will be there in the salt crystal?
10 into
10 to the
22.
1.2 into 10 power 18. Just calculate 1.2 into 10 power 18. Okay. So that 1.2 can be taken as 12 by 10. Okay, 10 power 18, 110 will be cancelled. So 12 into 10 power 17 atoms are present in single grain of salt. Every day you are taking through food, through what is that buttermilk, everything you are taking
Curd.
inside through vegetables, curries and all you are taking inside. How many types of atoms?
12
How many number
million.
of atoms? 12 into 10 power 17 atoms you are eating. Not only whole day, for just 1 meal. That too, not only one crystal of salt. How much salt they pour?
teaspoons of
Thousands and thousands of salt grains they will pour, right? So how many trillions and trillions of atoms you are consuming daily? Just imagine, right? So let us go to the next. So as we have seen, this matter of atoms cannot be created
not
nor be destroyed. How can we say that, sir? For example, take this picture. Burning of wood. After burning of wood, what happens?
ash.
Normally, what you will see
Ash.
is ash. Okay, ash will be remaining. So, by changing its state, can we say that wood is completely discapitated or disappeared half and half
No,
is
sir.
remaining as ash?
No, sir.
No. So I told you already, if 1 grain of salt is occupying our body, just take each atom is the size of ball. That means 1 grain of salt will be how much big it will be? Huh? See, one research is saying that 1 grain of sugar can contain 100 billion stars if they are that much smaller size. 1 grain of sugar can contain 100 billion stars. 100 billion stars means?
So many.
So many means not how much? So if you want to read each star per day, it will take 500 years to complete each star. Understand what I am saying? If you want to study about each star per day, you will complete 500 years of your age to complete all 100 billions of stars. Is that possible? Not at all possible. So our lifespan is also not even sufficient. So that many stars can be fit in single grain of sugar. That many stars can be fit in single grain of sugar. So that by that we can understand the total wood is occupying more space and it was burned into pieces of atoms and it became into this. So we did not destroy, we just modified, we just transformed it. Understood? So can we make this residue into again wood? Not possible. Okay. So let us see the next one. So here they are saying that oxygen is there, 2 atoms of oxygen is there, and when it is burning, it becomes into water vapor. That means it reacts with what? Water vapor means H2O. Very good. So H2O in the form of gaseous state. So it will become like a water vapor, and both will be mixed up together and release carbon dioxide. Understood? So we can call this as chemical reaction. What?
Chemical reaction.
Chemical reaction. So what is meant by chemical reaction? The reaction between two compounds. Reaction between two compounds or elements. Okay. So the reactants, so the elements or compounds which are getting reacted are called reactants. So once they got reacted, we get products. So this whole process is called chemical reaction. So when a chemical reaction takes place, the matter changes state from one state to another. So when a chemical reaction takes place, the matter can combine with another matter and forms a new matter. Okay, we are going to see in that video so that we can get a more clarity. Okay, so let us see the next big law of conservation of matter. So as we have seen, wood is converted into ash, but the atoms are present. How much mass of wood is occupied? That much mass is only present in the ash also. Like that, if you take a beaker of ice cubes, so how much mass is there in this ice cubes?
100 grams.
100 grams of reactants. So when they react with the heat and it becomes into
Water.
liquid or water, And then how much mass is there?
100 grams.
Still 100 grams. So it is not increased or not decreased. Got it? We can call that concept as
Law of conservation.
law of conservation of mass. Okay. So let us watch one video to understand how this law of conservation of mass works. We call that as balancing act. Let us watch.
During a chemical reaction, new substances are created from the original substances, but the total mass of the reactants will be the same as the total mass of the products. This is the law of conservation of mass.
So as you can see that how many types of atoms are taken? Sodium is one, hydrogen is two, oxygen is one, chlorine is one. So here also after getting products,
Same.
same. Any changes are there?
No,
So
sir.
extra atoms are added,
No,
so atoms are deleted.
No, sir.
So both sides are balanced.
Let's try an experiment to see how this works. Take approximately 7 grams of iron and 4 grams of sulfur.
So they have taken 7 grams of iron, 4 grams of sulfur. Now what happens when we mix these two? It
11
becomes
grams of
11
iron
grams
sulfide.
of what?
Iron sulfide.
Iron sulfide. Very good. That's what they have done.
Iron and sulfur react with each other to form iron sulfide. Let us look at the mass of iron sulfide formed after the reaction. Note that the iron sulfide has the same mass as the total mass of the iron and sulfur.
So as you can see, total mass of reactants is equal to
Total
total mass of
product.
products.
This shows that mass is neither created nor destroyed in the chemical reaction.
Exactly. So mass cannot be created, neither be
Destroyed.
destroyed in a chemical reaction, right? So, okay sir, in a chemical reaction, we cannot destroy, we cannot create. Normally we can do.
No.
Hmm? No. You cannot create normally. What is normal first of all?
Like,
No one knows. What is normal? What is physical reaction? Okay, you say physical reaction. What? Change in physical state. Very nice. That means if you blow a balloon and pop it, it will change its shape, right? What is chemical reaction?
chemical.
Chemicals mixed with together and forms chemicals. Different chemicals, right? What is normal reaction?
Normal.
Any normal reactions are there? So in this world, not only in this world, in the whole universe, in the whole creation, there are two things: physical reaction, chemical reaction. There is no normal reaction. Okay, sir, physical reaction is there. No, by physical reaction we can create atoms and we can destroy atoms, sir. Is that possible?
No, sir.
It is possible. You know, that is called Big Bang theory. You remember that?
Yes, sir.
In an atom, what they have done, they separated these neutrons and electrons and protons and try to bombard them. Bombard means collision.
Collide.
So when they collide together, how much energy it is releasing, they wanted to know. So at that time, your people are even very small at that time. So at that time, when that happens, they thought it may create a black hole that our Earth would go consume itself. Okay. So that much dangerous reaction they have done nearby Europe. Big Bang theory. Okay. So with the light speed, they send this neutrons and they collide each neutron with another. And then what happens? They wanted to see. If that happened, obviously it will create a massive strike of energy and it will create a black hole and our total world will be consumed. So they stopped the physical reaction with the atom. So finally, in chemical reaction, they cannot do anything. Right? So by this conclusion, what they have done? Atoms cannot be created nor be
Destroy.
destroyed. So creation, we are not gods. Right? So we cannot create anything. Even our hair also we cannot grow back with our power. Right? Am I right? So like that, atoms cannot be created nor be destroyed. So who made all this research? Who has given this concept to us?
John Dalton.
Very good. John Dalton. So he is the person who created all these concepts for us to understand how vast the universe is. So let us see about him. Dalton's atomic theory.
Dalton's atomic theory. Dalton's atomic theory was proposed by John Dalton, an English chemist, meteorologist, and physicist in the 1800s.
So many degrees are there.
According to Dalton's atomic theory, all elements are composed of tiny particles called atoms. Atoms of an element cannot be created, destroyed, broken into smaller parts, or transformed into atoms of another element. The modern atomic theory says that atom can be divided into a number of subatomic particles.
So now what he has said, atoms are very tiny particles which are available in every element. Okay. And next what he has said, these atoms cannot be destroyed, broken,
Transform into another element.
created. Okay. Not only that, cannot be transformed also. And these atoms can be divided into subatomic particles. Divided means they can separate?
No.
No. So to understand the concept, inside we can go of the atom. So there we can see subatomic particles. What are those?
Neutron.
Such as an electron,
Electron,
proton,
proton,
and
Neutron.
neutron.
and neutron. Do you know the charges of these?
Electron minus.
Electron?
Minus.
Minus. Very good. Proton?
Plus.
Plus. Neutron?
Neutral.
Means?
Nor positive nor negative.
Means what? Zero means what? No charge.
No charge.
No charge. That's it. Saket is listening very.
Atoms of the same element are identical in size, shape, and mass.
So, what did you understand with that point? Atoms of same element are identical in size and shape. That's why it has the same quality of that particular thing, right? Let us see.
It was later found that atoms of the same elements can have a different mass, as in isotopes of hydrogen.
So, which elements which has same types of atoms, they can be called as sister atoms or sister elements. We call those sister elements as isotopes. For example, copper has copper 1, copper 2, copper 3, that kind of isotopes. You know. So in next lesson we will learn this. Okay, we will see.
Such as protium, deuterium,
Right.
and tritium.
So these are the names for them. So if the single electron is there, protium. If dual atoms are there, deuterium. 3 means tritium.
Different elements have different types of atoms. Atoms of different elements can physically mix together or can chemically combine in simple whole number ratios to form compounds.
See, if 2 or more atoms are combined together to form a compound, right?
Chemical reactions occur when atoms are separated, joined, or rearranged. Atoms of one element are never changed into atoms of another element as a result of a chemical reaction. Summary. Dalton's atomic theory states
Tiny
that
particles
elements are
called
composed
atoms.
of tiny particles called atoms. All atoms of a given element are identical in size
Identical
and
in
mass.
size and mass.
Atoms of one element are different than all other elements.
If they are different with the elements. These three are the postulates or characteristics given by the John Dalton. Yes, Sagar? So as we can see, atom contains all these things. So electrons are the things which are revolving around the center. Next, protons are in the middle, which is present in the nucleus. And neutrons are also present in the center. And element is nothing but which has same type of atom. Compound is nothing but combination of two or more elements. So this is called a chemical reaction. So by this we have understood what is an atom and how small the atom is. And next
Molecule.
what we can do with these atoms. Right? So these atoms can be converted into
L.
can be converted,
No.
cannot be converted, or transformed, or destroyed, or broken. So by this we can understand, according to John Dalton's theory, these atoms are containing same type of element and which is having only same size in that particular element. Hope you understood this class, right? So today's homework is, when you go to home, take the elements, for example sugar, salt, so many things will be there in the powder state, like masala and all. So try to observe them and estimate your count by searching the internet. For example, grain of sugar, I have shown. Grain of salt, I have shown. Grain of sand, that also I have shown. Still, what are the powders are there?
Masala.
Masala powders or surf will be there at homes,
Yes.
right? And your powder will be there. Face talcum powder will be there. Pond's powder. Okay. And next, what else will be there? So many different powders are available at home. So write each name of that powder and find out the in single crystal or single type how many atoms are present. So that is your homework. Okay. Thank you so much.
Thank you.
Thank you, sir.